All right, so we're going to go someplace warmer. We're going to go to Hawaii first and then New Mexico. But parts of it are cold too. This is a study that I did with Jenny Hathaway, who's here, and Joe Medley, who's in Illinois, and Mike Spilde, who's here. This is just part of a bigger one, but we're going to look at some of the biosignatures that we see here on Earth and how those can give us clues for knowing how we're going to find life on Mars or other extraterrestrial bodies, which is something I got introduced to by Penny Boston, who basically told me years ago, I think we met in 1994, something like that, at a conference. And basically, I got introduced to the idea of one of the early articles she wrote about if we're going to find life in the solar system, it's going to be in the subsurface, in caves. And that introduced me to the idea and started expanding what I study. So we're going to start in Hawaii in Kapuka-Kanehina system, which is down in near Ocean View, where we go for a couple months. Ryan Stumbaugh, who's going to talk later, is doing his research down in the caves down there, and you'll hear more about what he has done there. What you see on the walls here is mostly entirely mineral crusts and something that we ignored in the beginning and went for the just microbial mats that screen microbes. Something that is important for the comparison I'm going to show you between New Mexico and Hawaiian caves. And these are the Hawaiian we'll start first with, and these are the New Mexico caves that we're going to talk about. One of the things we discovered is that there's a lot of copper and vanadium in these caves, both in New Mexico and in Hawaii. And there are organisms that I'm going to introduce you to that utilize these minerals. So we're going to start with Hawaii. This is the mineral microbe continuum. And one of the questions we wanted to know is how much microbial life is in these mineral deposits. Anybody know what this one is here? Anybody recognize that? Actually, Carol should recognize that.
I'm wondering why
I don't know.
so much copper in
Morning. How are you? Did you sleep okay?
It's
Where
gypsum.
she is? I haven't seen her. Could be gone, I guess. I'm gonna check see if the truck was here.
Okay, whoever is online talking, you're broadcasting to the whole room. Okay, so that's actually gypsum, and we're going to look at that. And I found it only in one of the caves. But we're going to go from mineral crust to coralloids, which I'm sure everybody's more familiar with, the gypsum nodules. This is something that we discovered basically in Hawaii, but it's also in some of the New Mexico caves. It's what we call ooze. Jenny Hathaway is going to talk later, would like to call it Uglia, which I have to learn to pronounce if we're going to do that. Okay, you're all familiar with moonmilk, but moonmilk in Hawaii is just amazing. It's like just big fluffy cotton balls. And in fact, the geologists I work with like to lick it to find out what it was made of. And I'm like, that's a terrible idea. Something in there could kill you. And then microbial mats that we're more familiar with. So we're going to start with the microbial mats. And to make it more friendly, I put over here the roll. If you're interested in who lives here, they're over here. But we're going to concentrate on the rolls. And so this is a white microbial mat. This is what it looks like in the scanning electron micrograph that I did with Mike Spilde. And there are several organisms in here that do different parts of the nitrogen cycle. And there are several that eat carbon, just like you do. The moonmilk, however, notice how all the roles that they do have expanded. Still got nitrogen, but some of the organisms in this help precipitate calcite. Some are able to actually use hydrogen as an energy source, which would be really important for finding organisms on Mars or other planets. And some like to live in the more alkaline, salt tolerant area of the cave. When you look at the inside of the organic ooze, which you see here, and I like to liken it to, it looks like somebody took a jar of baby food and threw it on the wall, and it just sort of oozed down. And you see a lot of this in the Hawaiian lava caves. And when we blow it up or look at it in detail, you can see these are these reticulated filaments that we've discovered in caves all over the world, and we have absolutely no idea who they are. We've worked on this for years. Other people work on it, and we got no idea what it is. But in the ooze, there's nitrogen and sulfur co-metabolism. They use nitrogen, and they produce bioactive compounds. In other words, this is a place you might find a new antibiotic. The coralloids are basically one of my favorite there. Notice they've got a whole lot of things too. They can precipitate calcite. They've got the bioactive compounds, hydrogen, and we've discovered this guy who Dan Jones down at New Mexico Tech just published a preprint that they basically think they are methanotrophs. They can eat methane rather than what they were known for. So that's changed dramatically in the last year, thanks to his research. And then my absolute favorite are the copper silicates. This is basically an article we did 15 years ago, but we managed to get the cover of Astrobiology with one of Kenneth's photos. And these guys, which I found them down in the southern part of the Big Island and over on the eastern side of the Big Island. And these guys they've got ones in there that use methane, nitrogen, sulfur, hydrogen, acetate, copper. These guys have just amazing abilities to do different things. When you look inside of it, a lot of it's just normal microbes, but all these strands are the reticulated filaments. And Mike got them to do XRD on it and showed that it was actually poorly crystalline chrysocolla. And so we now know something more about what's going on with this. We're now seeing this in cracks in the wall in one of the caves there. And I was just told a couple weeks ago, it may be because there's a swimming pool on the surface that's leaking. So, but I see this, like this is in one of the New Mexico caves. And I know there's not a swimming pool on top of that cave. So we don't know yet. That's something we'll investigate. And then the gypsum crystals, I was not particularly hopeful, but it turned out there's a bunch of different organisms in there. They use nitrogen, they can precipitate calcite, the bioactive, and again, there's some salt tolerant ones and ones that love it being basic in pH. So now we're going to go up on the slopes of Mauna Loa. I have 8 minutes left.
No, that's how long.
Oh, okay. So we're going to leave all the vegetation behind. And this is important because if you want to think about who would be on Mars or other ones, getting rid of all the vegetation is much more helpful. So we're up at 11,000 feet on Mauna Loa, looking across at Mauna Kea. You can see the telescopes over there. And then you get to walk across this, which is not much fun unless you can only get the smoother stuff. And this is one of the caves up there. So what am I sitting on? A lake that's iced over. It's that cold in those lakes up there. And we found mineral crust and microbial mats. And these guys have metabolisms that involve nitrogen, sulfur, but manganese and carbon. And my absolute favorite was I went in this cave and I noticed this yellow stuff. That is vanadium, which was, yeah, we did the analysis on it. It really is. Carol's looking at me like, no.
You know, the salt.
I'll show you in a second. By the way, here, there's basically a hydrogen eater and a methane bacterium that dominate in that yellow stuff. And this is an SEM of it. This is the peak that we saw in the SEM when we did it. And these are those deposits of the vanadium here in there. Mike can probably tell you more about that. I'll rope him in on the question. And then we're going to end our Hawaii time with a new cave that was formed about 6 years ago. This initial picture is Andreas Fletch hired luckily a very experienced helicopter pilot, and I'll tell you more about that in a moment, and took us up, whoops, well, maybe. Basically, we're up in a fairly big storm. This was a very experienced pilot, so he sort of navigated the storm, and we got to the cave, and he said, you have 20 minutes. So we're running through the cave, but it turned out the cave was still blowing steam. And Andreas had a special suit, and he said, well, I could put on this and go in. And I'm like, crazy. We actually basically got out of there, had to make an emergency landing to wait for the storm to pass a bit, got back up in the air, and I was sitting next to the pilot, and I heard the engine go, and then he's on his mic going, we need to declare an emergency landing. So you can have excitement out of the cave as well as in the cave. So we got to go back about 2 years ago in 2023. You can see it looks much nicer now, right? And we got to go in the cave. Kenneth took a bunch of pictures in there. Maybe he can comment more on that. I was able to get some samples, and the samples that Jenny extracted and we sequenced basically show that we have a methane generator, a sulfur oxidizer, a nitrogen oxidizer, and 2 other parts of the nitrogen cycle. So this cave is really new, and we're getting to see, who's doing what in just that amount of time. So now we're going to leave the warmth and come back to not just the cold here, but cold at 2,000 more feet of elevation out at El Malpais. And okay, we're doing all right. All right, so this is something that I've actually been working in El Malpais since a long time ago, the 1970s. This is Kate Hughes, for those of you who remember her in Xenolith Cave. We have a lot of the same structures. The moonmilk, though, in El Malpais caves is dry and sort of like sand. So it's very different. There's bare rock, which isn't bare, and there are fingers. There are also the copper mineral crusts. We have coralloids, and the microbial mats here are usually always white, but there are very few yellow ones that we see. And the ooze that we managed to find in one of the caves was basically sort of cracked and more dry. So it's a very different structure. And here are some scanning electron micrographs from El Malpais, which has a lot of different cool shapes, many with different fibers coming out from the things. And then these are some of the Hawaiian ones, which have spheroids that have a little protrusions on them. One of my favorite, beads on a string. And to give you an idea of how big they are, so if you look at this, yeah, leave it down here. This is a 2-micron bar. So who knows what the width of one of your hairs is? It's like, wow, biologists. Anybody want to guess?
100 micron.
Yes. So this is 1/50th the width of one of your hairs. So these guys are really, really tiny. In fact, those are less than a micron across. Really tiny. So what Joe did for his senior honors thesis was he took the DNA from the Hawaiian sample and from the El Malpais sample and sequenced them and compared them. And this is a graph that the axes mean nothing, by the way. NMDS is multiple dimensions and they just collapse them. But what's important is if you notice here, these are the El Malpais ones. Did I get that right? Yes. And these are the Hawaiian ones. Notice how the Hawaiian is mostly all together except for these outliers. Kulakai Caverns is a commercial cave. What? Okay, thanks. Is a commercial cave and they do tours, I think, every day now, right?
They're doing a lot.
Yeah, so you got people just coming in. So what are you all doing as you sit there? Shedding. Hair, skin cells, 10,000 skin fragments a minute, I think it is. Clothing fiber. And the microbes that are here are between the El Malpais and the Hawaiian, so that the impact humans have on the microbial community can be significant. So what we have know so far, and this is going to get expanded on by Ryan's talk this afternoon. So we've got a whole lot of secondary mineral morphologies that are not boring. They're full of really interesting different microbes. Lots going on with the nitrogen cycle, and this is particularly what Ryan will talk about more in both the archaea and the bacteria. So you guys have all heard of bacteria. I think Ryan's going to tell you more about archaea this afternoon, so I'll skip that. And then it looks like they do a very critical part of the nitrogen cycle in here. And we've got some new projects that are going to expand on learning what that is. And a lot of evidence that a lot of what looks totally mineral is a great place to look for life when you go to another planet. And I want to thank Kenneth for the photography. We're really lucky in Hawaii. The Cave Conservancy of Hawaii down in the southern part particularly is very supportive of the work we do. Several landowners, private landowners have granted us cave entry. State of Hawaii permit is like a bitch to get, but I got one. And then much easier was the El Malpais permit and the support by the staff there and a ton of assistance from a whole lot of people. And I think we have time for some questions. 18, I have 2 minutes left. Okay, questions. All right, start here and go to Victor and go to Mike.
Trying to find the advantages of what appears to be pretty much a low-venture environment.
Yeah, it was. Yeah, we're starting to find more, and what Mike did with finding that WB1P19 is involved in the methane cycle was particularly interesting because I find that all over the world. And it's from an original study in Australia, and it's never been named. So I'm hoping he's going to get enough data to name it. And that's a whole new thing he just discovered recently. So, Victor.
Did you see any gypsum 6-year-old longitude? I can't say we didn't. I don't know for sure.
Yeah, we only had a few hours in there. So, and I didn't take samples we didn't take mineral samples.
About half my time was spent helping the guy doing the video, holding lights.
Oh, right, yeah. I did not, but boy, the speleothems were amazing in a 6-year-old cave.
Lava
Lava speleothems. wasn't there one that was
There was a 2 meter soda straw.
a 2 meter soda straw?
We had to crawl a lot, not because the cave was so small, but because we had to get under the formation.
Wow.
And not break anything. No, they were just lava formations. It shows you what an impact humans have on the lava caves. Because the original, and I've been to one out at El Malpais that also has a lot more lava things. Mike,
Now, that picture of the 6-year-old cave. Looks like they're yellow, you know, the side of it, is that what I'm saying?
no, that was a microbial sort of mat. Do you remember that one, Kenneth? Wasn't it?
Yeah.
Yeah, that I took samples of and extracted DNA from it. It looked more like the beginning of microbial mats.
LM sample for it.
We might have an SEM sample to look at, Mike. Once we get out of the hole we're in now.
Very deeply, we always in holes.
Yes,
Have you looked at the Bingham Cave here in New Mexico that has all the copper, secondary minerals?
no. Where's that?
Bingham in New Mexico on 380 as you go between Socorro and.
I know where Bingham is, I don't know. where-
Yeah.
Is it?
There's a thing called Bingham Mine which intercepted a natural cave. And
Okay,
in the natural cave, many copper mineralizations.
wow. Is it
Yeah.
privately owned?
Pardon?
Is it privately owned?
Yes. Yes and no. The owner, we talked to her and she said, yeah, she owns it. When we talked to BLM at another time, they said, no, that's BLM land. So I don't.
So ask them both. Okay. I'll get some information from you later. Anything else?
John, that's not the lab.
No, it's San Andres Forage.
Long time.
Yeah, in fact, I went there with you. First time I saw her.
Sounds cool. Okay, thanks.